Hi everyone, welcome to this video on high availability on Cisco ASA. My name is Kingsley and I'd like to welcome you to the video. This is the topology I'm going to be using for to demonstrate or implement the high availability for the ASA. Just a little background on high availability. Why would you want to implement high availability on your network? Of course, it's to provide resiliency, redundancy. In every computer network, we always strive to remove a single point of failure so that it doesn't affect your customers or your users, right? In this video, the focus is on the ASA. And of course, when you look at the design, we also have a single switch here, which if it goes down, then it results in failures. Yeah, so we can talk about the switch in a different video, but the focus here is on the ASA. Now, different vendors have different ways, different implementation of their redundancy for the ASA. Cisco supports clustering. You have multi-context. You also have, of course, the active standby availability or that implementation as well. So you should also check Palo Alto, Checkpoint, and so many other vendors. They also support these implementations. But the focus of this video is just to show you how you can have ASA in active standby mode. Now for this topology, we are using virtual ASA, virtual devices. They are not physical hardwares, and we should still be able to achieve a pretty good implementation for high availability. I'm using ENG, right? Here, so this is the actual lab that we'll be using, but this is just more of the diagram. Right, I mean, gives us more like a low-level design of how the network is. So this is our London DC. The entire DC, the entire network is running on 10.0.0/16. That is of course the LAN where the two servers are connected, and the gateways is on the ASA. The switch here, this is an arrestor switch, very good in for demonstrating. Exactly, the switch can support both layer 2, layer 3 routing, but of course in this topology it's just forwarding VLANs basically. So the internet comes, this is your internet comes, hit the switch. This is like of course the top of rack switch, and then we take it to the firewalls, right? These dotted lines, the green represent the internet that comes and then goes through VLAN 20 to the two firewalls. And then you also have another VLAN, which is VLAN 10, that goes to the servers. Now the ports here are all access ports, except for yeah, they are both access port except for because this is G0/0 here, or Ethernet 5 on the switch. So this needs to forward these two VLANs. So this is trunk links. So Ethernet 1 and Ethernet 5 are trunk links. Ethernet 6, 7 are access. Ethernet 4 is access. While Ethernet 2, I think it's also access because okay, yeah, so Ethernet 2 and 3 are both access ports. So one port goes to server 2, while the other port goes to server 1. So we only have two trunk links, the other are access, and then yeah. So yeah, it's really just a basic implementation. So this is the entire data center, and then this is a public IP. I know it's a private IP, but of course it's a lab environment. So we assume this is our public facing, right? So the traffic comes, hits the switch, and then hits the ASA. Now, as you can see, the device are already fired up, so we should just get console access and then we can begin our implementation. Now, talking a little bit about how you implement active standby failover on the ASA. It's really 4 commands that actually do the job, right? the failover, then you need to, now for the failover to work, there has to be communication between the two ASA. So they are going to be sending hellos, right? Checking on each other. So this device is going to always be checking on the active. Are you there? It's going to reply, yes, I'm there. So they do that with the hellos. And then whatever you configured here is going to get replicated to the standby. That makes it very okay, because you don't, it's not like you come here, you configure something and then you have to do it here. No, whatever you do here automatically get pushed to the secondary. And we have this failover link that is going to be used, right? So both the hellos and the replication of config is going to come through this interface. There's also the third link that you need, which is for stateful replication. Now for failovers on ASA, you can either implement the stateless failover or stateful failover. Now for the stateless failover, what that means is the tables that are built on this ASA, like your app table, your routing table, your cache, your MAC address tables, those informations are not replicated to the secondary, right? For stateless implementation, failover implementation. However, for stateful implementation, it means every tables you have here operationally gets replicated to the secondary. So if you come here and do show routing table or show MAC address table or show app table, it's going to be similar. So there's always that active replication. So a lot of, there's management, but a lot of traffic is going to be coming back and forth between the two ASA, right? So in most cases, it's always recommended to have a dedicated link for that, which is what we did here. In fact, I initially tried to use the VLAN sub interfaces, but it says you don't use, it looks like the ASA doesn't allow you to use sub interface or shared interface for stateful replications, because I tried to use the VLANs, but I had to come back and use the physical interface, right? So yeah, I think those are the basic things you need to know about this implementation. So what we just need to do now is to turn it up. So before we do that, we need to be sure that these devices can talk to the gateway, and then every connectivity outside failover configuration is working. So I know I've already gone ahead to do some things, so we can just test this. So if I come here and say show run interface, so as you can see, the G00 physical interface is currently shut down. So let's bring it up. Config T, and just gonna say no shots, right? So that brings up the physical interface, and then if I come now and say show run interface, so we already assigned the IPs. So yeah, I told you the entire subnet is 10.0.0/16. So here I'm giving it 10.0.0.254. right? 255.255.0.0, and of course you also have this additional configuration that is added. This is really optional, it's not needed, but if you want to be able to monitor this interface on the standby end, right, to be sure everything is good, then you need to add the standby IP. Same for VLAN 20. Don't forget, this is what brings the internet in to the ASA. Yeah, so we are using 1.30, and 1.31 goes to the standby. Another key thing here is the MAC address, which is hard coded. It's always good to have your MAC addresses hard coded. It's really optional, but it doesn't mean if you don't have it, won't work. But the whole idea is when the active goes to the standby, you want them to be able to still maintain the same MAC addresses, right? You don't want the MAC addresses to change. Okay, so if you don't configure the MAC addresses here, in this case, when this goes out of production and it goes to the secondary, remember the BIA for this NIC will be different from what you have here, right? So hard coding it makes sure that when there's failover from the primary to the secondary, that the MAC address is still the same, and so there's no need to reflood or relearn MAC addresses on the switch. And so it's going to make failover seamless with no impact. In fact, we're going to demonstrate it, and we're going to see if you're going to be having any packet loss when there's a failover replication between the two ASA. So in this case, these are just MAC addresses that was auto-generated, because if I say show, let's do something here, show interface this, show yeah, so as you can see, this is the MAC address that is on that interface. Yeah, so those are really the basic things. So the next thing we need to do is to check that this ASA, these two servers can ping the gateway. I don't think I've assigned any IP here, so I say ifconfig. This is Tiny Linux, like I said before. I don't know if I said it before, but it's just Tiny Linux used for testing. So we need to, on Ethernet 0, right? So we need to assign IP and also give them a default gateway. So the command is so we need to, I think we need to do sudo ifconfig Ethernet 0 10.0.0.20. The net mask is going to be 255.55.0.0. But something spelled wrong there. Okay. Then we need to also add a default gateway routes. I think the command is routes add default gateway, and then we said it should be 10.0.0.254. Perfect. So let's see, can we ping 10.0.0.0.254? Yeah. Can we ping ourselves 10.0.0.20? Yes. So so the associability between the server to the gateway. Let's also do it for server 2. So the login is GNS3 ifconfig sudo ifconfig Ethernet 0 10.0.0.10. The net mask is going to be 2525/16, and route sudo route add default gateway is going to be 10.0.0.254. If it's working, we should be able to ping the gateway. Fantastic. And also we should be able to ping ourselves. Of course, we should be able to ping ourselves. Okay, so here on the this is the ASA on the switch. I already said there's really nothing special on the switch. Show interface trunk shows you the trunk links. So like I said, port 5, right, and port 1, which is this. So these two links, which is more like the north-south traffic, is what is only trucking. The rest are access. As you can see, this goes to VLAN 30. We don't really have. Do we have VLAN 30? Okay, we don't have here. So I think there's some mess up here. So I don't need VLAN. I don't need VLAN 30. So I'm just going to take that out. No VLAN 30. And no VLAN 40. Okay, so show VLAN brief. So VLAN 10, of course, this represents the inside LAN, and so VLAN 20 in this case should be name internet traffic, and VLAN 10 should be given the name LAN traffic. Okay, so yeah, so sure on. I want to say this Ethernet 6 is for Ethernet 6 and 7 should just be using the default VLAN. Yeah, so if you see it here, they're really on VLAN 1 because they are not really, they're physical interfaces, and we don't need to create a VLAN for that. It's in the default VLAN. Sure on. So if you say show VLAN brief, yeah, so everything is okay now. So this is internet traffic, this is LAN traffic. We can decide to move the 6 and 7 to a different VLAN as well. Maybe we should do that. What do you think? Sounds nice. So we say VLAN 30. I will say failover traffic, right? Failover traffic, and then so name should be failover traffic, right? So we're now going to say interface Ethernet 6, switchboard mode is access, switchboard access VLAN 30, interface Ethernet 7, which is this interface that goes to the secondary. Switchboard mode is access, switchboard access VLAN 30. So show VLAN brief. So we should yeah, so we should be good now, right? Yeah, we don't really need internet stuff. Is we want to be on VLAN 30, but it doesn't really hurt. So we're just going to leave it like that. So let's go to the actual reason for this the actual reason for this video, which is the failover. Now for the failover, you're going to need basically it's 4 commands really to turn on failover. You need to do it on both devices. The configuration is straightforward. First we're going to say failover LAN units. Just a sec. Yeah, I want to see everything. So we're going to say failover LAN units. Here is going to be primary, right? Because these are primary device. And then we're going to say failover. Failover is to the question mark. We have the interface, right? Failover, I think it should be LAN interface, right? So the interface is going to be, we need to give it let's see, question mark, we need to give it a name. I'm just going to call it failover link, right? And then we need to give it what is the interface. So in this case the interface is G0/1, which is G0/1. It says non-failover interface config is cleared on G0/1 and its sub interfaces. Okay, so that is done. We also need to assign the IP, right, for the failover. So we're going to say failover interface IP. So the name of the failover link is failover, right? Then we're going to say so typically you want to use 169.254. You want to use an IP that will never at any point overlaps with your network. So I'm going to use 10.1.255.255.0. So and then the standby 2 is going to be 169.254.10.2. okay, so and we also need to add we talked about stateful and stateless, so we need to say also replicate the link state, right? So failover link here is going to be this. I know the config used to be failover link state, but in this case, the current code we are using, you don't need to specify that. So I'm just going to say failover link. In this case, it's still going to be the G0/1. Okay, so to see the entire command, we're going to say show failover, show run failover. All right, so this is the entire config. Right, so failover LAN unit, failover LAN interface, specify the interface for the failover, and then for the link, stateful replication, and then of course the IPs for both the primary and the secondary. So the config here is entirely similar to the secondary. The only difference is here we're just going to say secondary, right? So I'm going to copy everything here. take it to the secondary. You see, even the host name, you don't need to specify anything. It's just say config t, no this, and then poof, right? So if I come and say show failover, show run failover, so that's the only thing we need to do here. And of course, we need to turn it on, and then this is no failover with disable. This has to do with when you cannot reach the primary, how long should you wait? I think that's what this is about. I'm not 100% sure. So what we now need to do is to just turn it on. Now, if you want to turn it on, you need to turn it on the primary first, because if you turn it on the secondary becomes active and becomes the primary. And what happens? The secondary is going to replicate its config to the primary. And here, do we have any configuration here? Nothing. So you want to do it on the primary first. So we go to the primary and say failover. Yeah. So it's going to come up. It's going to try to detect the secondary. It's going to tell us if it says the secondary. If it doesn't say the secondary, it's going to let us know. It's going to just turn to active. So if we say show failover, let's see, unit 1 second hold time, pull 5 seconds, monitored, MAC address notification interval is not set, failover, last failover days. So let's see, show failover. Okay, we should have gotten a log that says the failover is active, but let's see what you're seeing here. Oh, so the problem, the physical interface is still down, so we need to bring that up. My bad. So you see, we did not put this description. I think when we configured it, automatically apply this description to the failover link, right? So, but we need to bring it up. So let's see, we should get a log, a message that say if a peer is detected, if failover peer is detected or not. So let's see. So let's say show failover. It says failover link gigabit 0 fail, no switch over. Okay. What does that mean? Let's see. So if we say show failover, you see failover is on, and say this is LAN unit is primary. It's a failover LAN interface. Failover link is this. It's a failed. It's a no switch over, right? Unit pool, and so he's saying who is primary. He's saying it's currently the active. He said the so he is currently the active because he's not able to detect the standby device. So what we need to do now, what I think we need to do is to enable failover on the secondary, and then we see what happens. So let's say failover, so it's enabled. Let's hit save. Let's see what happens. So if it detects the primary, then so maybe here we can say config T. Before we lose our configuration, we need to say failover active. Let's see. So show failover. It still says no. So we really need to be sure that the failover link is okay. So secondary says no active detected. Exactly. So there's probably something wrong with the show run interface. I thought, oh my goodness, I did not bring it up. Okay, so let's see. They should detect each other now. Okay, now the failover link is okay. Okay, and replication is ongoing. Fantastic. Well, that's why we make these videos. It helps us to say end replication to mate. So if you go to the secondary now, it has replicated the entire config from the primary, right? So you see the name automatically changes, right? So it's saying this is London DC firewall primary. And so if you say show failover, yeah, so the failover link is up, and it says pool frequency is 1, hold down is 50 seconds, and it's a monitored interface is 0 of 311 maximum. It's a MAC address move notification interval not set. Failover, last failover was 1123. It says it said active. It said the host is, it said this is secondary, right? It said other host is primary, so that's what it's telling us. And then this is the stateful replication we're talking about. So you see different type of information, stateful information that could be shared between both devices. You say the app table is being shared, is being received. The general control plane information is also being received. System commands. So currently we only have the app table. Maybe when we configure NAT table, you're also going to see replication for NAT and other type of traffic. But at least we are rest assured that it is being replicated now. Now, one thing I want to fix here is, you see this place, it says the inside link is not being monitored, right? So I think what this really does is, so currently what is being monitored is just this link, right? Now what happens if this link fails, the LAN link or the internet link? What happens if it fails? The ASA will not be able to tell this guy, the secondary, that, oh, this link is down, that he needs to see. So there has to be like a sort of monitoring for this link. So what we can do with that is, what that can help us do is, so let's go back to, now for us to monitor those interfaces, what we need to do here is say monitor interface. That is just a command. You say inside, I think that's all. Monitor, I say warning, replication is not performed. Oh, we should do it on the primary. So that's something I should have also said. Now on the secondary, you cannot configure anything. In fact, when you try to go to the global config mode, it should warn you. Config T, it says configuration location is not performed from standby unit to active unit. Configuration are no longer synchronized. So it's not like it will not allow you to configure anything. You will configure, but the config will never be replicated to the primary, right? So it's always better to do it from the primary, and then the config automatically gets replicated to the secondary. Now, how do we even know who is the primary? That's another question, because they all have the same prompt, right? They all have the same prompt. I think we can change that by going to the global config mode and say prompt, give me the host name, give me the priority, give me some other information you can say. You can say, give me the context. We don't really need context here. And also give me the state. So I'm just going to take context out. Right, so fantastic. So now we know that this is the active device. If you come here, you should change. You see, this is the standby. Now you know which firewall is active, is primary, and which is the secondary. So something we're also talking about is the failover monitored interface. So we can monitor the interface by using the command monitor interface inside, right? So we're also going to say monitor interface outside. Yeah, I think that should fix those questions for us. So give you some time. It should not turn to, so it's already normal. Now it should change to monitored. Fantastic. So the interfaces are now being monitored. So if you also come here and do show failover, yeah, so the interfaces are now being monitored. Now the question is, now let's do some tests. Let's see if we can be able to reach the internet. So from here we already have the IP configured. So, but I don't think we have the default route yet. Show run routes. Show routes. So we don't have any default route that will take us to the internet. So let's configure that. So I'll say routes outside. I hope we're in the primary. Yeah. So anywhere you are trying to reach. So my gateway in this lab is 1.1, which is coming from the VM. So I believe with this we should be able to hit the internet. Yeah. So should be able to hit 4.2.2. Fantastic. And then save. If you also go to the standby, this should have been replicated. Show routes. How cool is this? Show run routes. So you see, anything we do here automatically is replicated to the secondary. So we need to test the internet, right? So let's go. So here, you know, for the servers to go to the internet, we need to configure NAT, right? So I'm just going to, let's say show run objects. I don't think we have any object here. So I'm just going to create a network object for the entire /16. So say objects network 10.0.0.0.0/16. Just give it a description. It's a LAN subnets. Call it entire LAN subnet, and the subnet here is 10.0.0.0.0 255.255.0.0. Fantastic. So if you say show run objects, so we have the object, so we can configure the NAT for that LAN object. So you just say NAT inside to outside. It's going to be source dynamic, and then we're going to say NAT this to, so we're just going to NAT it to the interface, outside interface. Yeah. So show run NAT, save. If you go to the secondary, show run NAT. How cool is this? Okay, so with this, I believe if everything is working fine, we should be able to hit the internet from here. So we can hit the internet. Let's be sure what is going on. It's good troubleshooting, right? Ping 8.8.8. Nope. So let's go back and say show run NAT. So we're saying NAT from inside dynamic if it's coming from 10.0.0/16. So let's be sure. Show run objects. We said it's 10.0.0.255.255.0. Right? So anything coming from here should go. So let's just show xlit. Yeah. Now we need to, by default, the ASA does not inspect ICMP. I just remember that now. So we need to create a policy to say it should expect XMP, because if you say should run policy map, I think it's usually global underscore policy. I think this should be it. So we don't even should run policy map. Say global underscore policy. Yeah, so this doesn't even exist. So we need to create it. There's a short command for that. I think it's fix up protocol ICMP. So fix up protocol ICMP. So what this command is really doing is going to create a class map and policy map and then tie them together. So we're going to see how it works now. Converting fix up protocol to MPF. MPF stands for modular policy framework. So it's just going to create the class map and the policy map. So if you go back again and say show run policy map, now you see it's now created. There's also a class for class default, so show run class map. So this command here, which is really weird, right? Because it wasn't, I think it's probably a new implementation from Cisco. So this command here automatically generates the class map and the policy map, right? And then with that, I believe we should be able to hit the internet now. Still not working? Strange. Okay, so let's be sure, but at least we can hit the gateway, right? Let's even be sure we can still ping the gateway. Ping to 10.0.0.254. Yeah, so we can still ping the gateway. But we can't, so let's do route N. Let's be sure it's able to forward. So here we said if you are trying to reach anywhere, forward it to the gateway. So something else we can do is to show run NAT inside source dynamic. Show run interface G0.20. Okay, so it's been NATed to 1.30. Can he ping the internet? Yes. So what we can do, we can use the packet tracer. Let's see what it's the problem. Right, so I remember something. Okay, now something else you need to know is this. So here we are using sub interfaces, right? Now for the ASA, we are doing something like an interVLAN routing, right? So there's interVLAN routing between VLAN 10. So the traffic comes, it hits the gateway on VLAN 10, but it needs to route out on VLAN 20. Now they are on the same physical interface. And so by default, we need to add a command to fix that, which is same security inter traffic, same security permits inter interface. So with this, so there's inter, there's also intra. This intra has to do with things like helping. We could talk about that in the future, where traffic comes, hits the interface, it comes out back on that same interface. So this should fix the configuration for us now. Yeah, so now we can reach the internet, right? Now we are able to reach the internet. So from here to, I should be able to ping the internet. Fantastic. So there was really nothing wrong with our configuration here. So if I say show failover, yeah, so failover is still on. And then if we go to standby now, show failover, right? So yeah, so you see that see a lot of tables are being replicated now, like the app tables. These are general informations, control plane informations that are being replicated. Is there anything xlate? There's xlate timeout. I was thinking there will be maybe like a NAT table, because if we say come here and say show xlate, you see there's the NAT table, right? So if you also come here and say show X late on the standby, so it's not been replicated from what I'm seeing here. I was expecting that the NAT table will also be replicated, but with what I see, let's say show NAT. Okay, the configuration is just there, but it looks like the NAT table is not very clear. Okay, but if we say show app, let's see app. Okay, seems the app table is being replicated. Let's see. Let's compare to the primary. Show app. Yeah, so I think it looks the same, right? Standard 10. Yeah, so because you see 192.168, the MAC addresses look the same because you can see this here. Yeah, so you see this MAC address for the outside interface. What about the IP? Okay, so these are the MAC addresses I was really talking about. So these are MAC addresses for these two servers, right? Yeah, so you can see here we're also learning about the MAC addresses of those two servers. So the app table is replicated. I'm not sure about the NAT table. I was expecting that the NAT table was also replicated. But what we can do is, let's see what is the impact of failing over traffic, right? So we are going to go to the standby and say failover active. So he's going to take over from the standby. He's going to say, oh, switch into standby is active. What happens? There is no drop. That is the most important thing we are trying to implement here, that switch over from the primary to the secondary, there is no drop, right? There is no drop, right? Of course, we force that failover. So now what I want to do is, on the secondary, look at what I want to do. I want to issue a reload. Reload, say confirm. Let me save the config first and then issue a reload. Hit enter. So it's going to a reload. Let's see, is there a drop? Nope. How cool is this? So you can basically lose a firewall, and if you are sleeping in the middle of the night, you just get an alert that, oh, firewall goes down, but it's not going to impact your traffic or in a peak period during the day. It's really something interesting, and one of the reasons why I decided to show this video is to also, it makes me know it better. And you know, when you're troubleshooting something tomorrow, because I work in an environment where I do a lot of I manage a lot of devices which cut across multi vendors, and not just for me but for my users and my customers. So this also helps me a lot to have better understanding of how these things should work, and you're better able to troubleshoot when an issue breaks up. So let me know what you think. The video is a bit long, yeah, because it's not like we're talking too much. So yeah, we're going to wait. I'm going to pause the video, just allow this device to boot back up, and then I'm quite sure he's going to take back the active row and with no impact on the traffic coming from the servers. Thank you so much for this video. In my subsequent video, we're going to be building site-to-site VPNs, right, between this firewall that are in high availability mode now to the different data center. Site-to-site VPN is pretty straightforward. So we're going to do that. We're going to do something interesting here where you have overlapping IPs. So as you can see here, we have 10.0.0/16. Here we have 10.0. So it overlaps with /16. So we need to do things like identity NAT to implement that. We're also going to do remote access VPN. So these are videos really related to real world implementations of how these things works. So let's say, for example, you have a user here and the user needs to be able to access all the servers within the 3 different data centers, right? How do you implement that? He's going to come and hit this firewall, route through the tunnels, then to this site. How would you make that work? So if you want to see those videos, you want to subscribe. And then, so when the video comes out, you'll be the first to see them. Thank you.